Okay, we have homework due today, assignment A4, I think. Okay, so I wanted to say one thing about 10.6. 10.6 is a series of questions about specifications, and remember that the preconditions for these depend on whether or not you're talking about computing a sum or computing a maximum. So don't forget that. Does it make sense to have the sum of an empty segment? Yes or no? Does it make sense to have the sum of an empty segment?
No.
It does, because if it's empty and you take the sum of it, the sum is what?
0.
0, right? On the other hand, does it make sense to have the maximum of an empty segment? The answer is no, right? Because in order to have a maximum, you have to have at least one element. So don't forget the preconditions for 10.6 depend on those two. I mean, you might need to use that information for that, okay? All right. So, what do you think?
It looked kind of long.
Confusing.
It looked kind of long. It's longer than the previous one, that's for sure.
I just don't know if I did it right is the issue.
Oh, I see. So you did them all, but you don't know if you did them right. But then, yeah, you
I
know,
could be wrong. You know?
you're right. And because these are not proofs, like when you do a proof, you can,
know if it's right.
yeah, you can tell if you got it or not. But these, yeah, you're right. I understand your frustration.
So for like 10.6e.
10.6e.
Yeah.
All right, and all right, so let's talk about that, 10.6e. And what was it in English?
It says calculate the greatest power of 2 that is not greater than n.
Oh, I think that's the hardest one of this set.
Oh, let's do
Makes
it.
me feel good about them.
The
I used in implies in it, but I don't know if that works.
I didn't.
Because these are specifications, right?
Yes, these are specifications. What did you have for the
Precondition?
precondition?
I said n is type integer and n is greater than 0.
Yeah, that's what I said.
And then I said
N is greater than
e
0.
is replaced by.
Okay, so do the postcondition again. So here we had the pre, then we had this, and we had the, and what did you say for the post?
I said for all I, range 0 is less than or equal to 2 to the I, is less than n. Then I said body p equals I. And then I said that implied
This whole thing implies something?
that for all m,
For all
I just said
m?
yeah, range m is less than I. Body 2 to the m is less than 2 to the I. That's why I said I don't know if I did.
Well, yeah, this doesn't look good. We'll have to think about it, but I'm not sure. I don't think doesn't look promising. But well, let's try to think through this. Now, so what is this saying?
It's a good effort.
What?
I'm saying that.
So
okay.
what did you mean to say here? What you meant to say? This says for all I.
So,
How could P equal I for all of these?
so there exists then.
Well, how could P equal I?
I'm saying that for one of them, p equals I, and that implies that that one's.
But how? But I mean, here you have a whole bunch of. Here you have i's. You could have a whole bunch of possible values of I, like 3. I don't know. What would the possible? I don't know. 1, 2. Well, I could be 0, 1, 2, 3, 4, etc. Now, how could P equal I for all of
No, as I
those?
said, it needs to be an exists.
Oh, so now you're changing this to be there exists. Okay, so now what you're saying is that there exists an I. There exists an I, so the I is 1, 2, 3, 4, 5 up to n, such that P equals I. So it could be equal, it could be any one of these. It could be A small one or a large one?
But that's what I'm saying, it implies that that one's the largest one. Because then I said for all m that are less than I.
Yeah, and by the way, you see that this 2 to the m less than 2 to the I, since it's, since this 2, since the exponential function is monotonically increasing, you could just as easily have said m less than I, because if 2 to the m is less than 2 to the I, that's equivalent to m less than I. You see what I'm saying? But, so you could simplify this.
So the range in the thing would be exactly the same. The range in the bottom.
Oh, that's right. Actually, this is always, yeah, no, this can't be right, because this is always true, right? I mean, what you've written, this is true, this is just true. For all m less than I, 2 to the m is less than 2 to the I. So this whole thing is just true. So you have this whole thing implies true. So basically what you have is just this. Oh wait, what is p implies true? Do you see what I'm saying? I think this is, see, this cannot be right. This cannot be correct, because this whole thing is true. And so what you have is this implies true. What is x implies true?
X.
Is that x or is it
Yeah,
true?
left identity. Like that's not. It's not right.
Ah,
It could be false or true.
Yeah.
no. What is x? Come on, look it up. Get your equation sheets out. What is x implies true? What is that?
X.
Is it?
Yeah.
No, it's true.
Or is it true? Well, look it up. Come on, you've got your equation sheets.
Because it matters.
Look it up. You've got your equation sheets. What?
The only thing that's
It's,
false is if true implies false.
P implies
Everything
true
else
is
is
true.
So this whole thing is true.
It's right zero.
Right
And then
zero.
it's
It's
left,
the right zero.
right zero, left identity.
Yeah. So this whole thing is true. So this whole thing is just true.
So
So this can't be correct.
there.
You see what I'm saying?
And R is guaranteed to be true.
So yeah. So I think we analyzed your,
Oh, I knew that it wasn't right. I just.
but have no idea. Okay, so so what do you want to say? You want to say that, well, there's several different ways to do it. One way to do it, you might consider this. So let me give you some hints. Okay, actually in my solutions I got 3 different ways to do it. One way to do it is, so one possibility is use this operator. Use the max operator.
Okay, but I don't know how to do that because you have so many values and you don't know what n is, right?
Well, but I'm here, and you can do this. You can say max over I.
Oh, I didn't know that.
Well, that's what I'm saying.
Can you just say like max parentheses?
Well, you quantify this. This is quantified. So this means max,
that's
max,
actually-
max, max. You see what I'm saying?
Oh, that's
So you
sick.
can say like p is equal to that.
Yeah.
Okay, and then for your range, what do you have to do? From
Well, yeah. Well, see, now that's enough of a hint. I think I'll let you chew on that. Otherwise, but you can do it without max. You might consider doing it without max.
Yeah, show us how to do that.
Okay, so another way to do it, so here's another possibility. Another possibility for a hint would be this. You could say, this is all the post condition, right? Okay, so another possibility would be to do there exists an I, blah, 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 which I'll let you figure out, okay, and now what are the free variables in this? Read the question again. What do we have to work with for the free variables? Don't we have a
Just n. Calculate the greatest power of 2 that is not greater than n.
right? But you called it.
I said p.
You said p. See, the reason I kind of don't like p is because p is kind of like what we use for logic for booleans.
Oh, I just said power.
Yeah. Oh, power. Oh, okay. P for personal preference. Okay, but anyway, let me write it D here. Okay, but what I'm saying is you could write like this. There exists an I, and you could say something about D. You could say D is less than or equal to something is less than 2D.
I don't get it.
Yeah, this is a hard one. Actually, this is the easiest one. And I had a student last year who has even a very slick one, which was which doesn't use any quantification, no max over this, no there exists. He was able just to do it with one simple Boolean expression. And it was the first time, I had ever, in all the years that I've been doing this and assigning this, he came up.
2 to the p is less than or equal to n?
Very close, very close, very close. Plus a little, yeah, it was, and even better than the solutions manual that our author has in the book.
Did you email the?
I don't know if I don't know if I emailed him this one or not. But anyway, you picked the hardest
Did you
one
email
to
my parents?
discuss.
Wouldn't
This is a
that-
hard one.
Wouldn't 2 to the p less than or equal to n still work?
Very close. Very close.
Why does it not work?
Well, you'll just work. You grapple. You think about it. Think about it.
Because it's not the greatest. You don't know if it's the greatest power.
Well, just
What if you did p minus 1?
Oh, now you're starting to think. Now you're. Yeah. Anyway. So anyway, just keep thinking about it. Just keep thinking. I don't want to write down the solution. So just. But you're very close, I think, with these. Okay. Any more? Any other questions? Any other ones that were particular? You did pick, I think, the hardest one of this set. You want to talk about another one?
Yeah, any of them would be great.
Well, which ones?
The 10-6 ones or those ones?
Well, we don't have time to do all. We don't have time to do the whole. Talk about the whole, every single one, or we'd be here all day, all hour.
I'm fine with that.
Just we're giving
Well,
hints.
I mean, up to the 50 minute.
10.6D.
Yeah. It's where you have to sort it.
Yeah, but see, 10.6D, I think, didn't I say you could use perm and ascending?
So you need to use both of those, right?
Yes, you
Okay,
do.
That's my only question.
Yes.
Perm?
Perm is a permutation.
Give me a hair term.
Perm.
You didn't say that on the hint.
I didn't say that on the hints? Perm and ascending? I thought I did.
I wrote down all the hints right here.
Didn't I say perm?
No, you did. I don't think I would have gotten it otherwise.
She
Oh,
said
it's in the
that?
book.
Oh, it's in the book.
Oh, in the book it says perm, and then on my website I said ascending. Yeah, you understand what? Yeah, he gave you a hint to use perm.
What does perm do?
It means
Okay,
that
yeah.
goes from 0 and goes to n.
Yeah, here's for example, if you say perm, BCN, what that means is that B, if you look at B and you look at C, and here in this case n equals 1, 2, 3, 4. For here in this case n equals 5, right? What that means is that if you have like 19, 23, negative 6, and 4, you might have like 19, 23, negative. So perm BCN is true in this case.
Oh, if one is a permutation.
If one is a permutation of the other. That's what. So it's a predicate. It's true. What's the definition of a predicate?
True or false?
A what? A what?
It's a proposition.
No.
Boolean expression.
No.
A predicate.
A predicate is a what? Function. It's a function that returns what? Type Boolean. Yeah, it's a function that returns. So this is a predicate. It's a function that returns type Boolean. It's either true or false. And similarly, ascending is a predicate that would. In fact, I think I asked you to define ascending in 10.3, right?
No.
Yes.
Yes. Ascending, 10.3 is to write down the, so now that we have, written down what ascending is in 10.3, we can just use ascending, and if you wanted to, you could expand it out. By the way, you guys, this perm BCN, I challenge you. This is a tricky one. I didn't ask it, and we're not going to pursue it, but if you want something to do for fun, try to write perm BCN equivales and try to do a quantified, try to define this formally.
Extra credit?
It's not easy.
Is it extra credit?
If you get it right,
Yeah.
yeah, if you get it right, but I don't think.
No.
Okay, there's your challenge. It's tricky because, you can have more than one thing in here. I mean, you could have, you could have
Well,
19 twice.
Is that function undefined if they're not the same n?
Correct. They have to be the same n. Because there's only one n. There's not an n and an m. So it only has 3. So 2 arrays and an integer.
Doesn't it make them the same? Or sorts them, I mean?
Well, they're in different orders here. But everyone that's in here has to be in here, and everyone that's in here has to be in here.
Last semester.
Anything else? Any others? Want to do one more?
On the last one, the n.
And
Use an implication in the precondition.
I didn't, but it might be possible to.
I did again.
Okay, so tell me read me what n is. This is 10.6n. 10.6n. And what is it's to specify what?
It says set x to true if integer array b contains a negative value.
Set x to true.
Z. Or x, yeah. Oops.
No, is x a Boolean?
It must be. It doesn't say. But if you said
Well, if you say set x to true, it must be a Boolean variable, right?
I would assume.
Okay, so here my hint for this is, if you have something like this, there exists an I ... What is the type of this whole thing? It is Boolean, because this is either true or false.
Okay, so if you did that and there
So-
exists one that's not, or there exists one that is, set x to-
This whole thing is Boolean, and you want to set x to a Boolean?
Yeah. I'm just trying to figure it out. Because it can, if you said it's true if it contains a negative value.
Yeah.
You're saying if it doesn't?
Well, if it doesn't contain a negative value, then it should be set to false.
Okay.
Yeah. But whatever it is, it's set to a Boolean. But my hint is, this expression is already a Boolean. Is it not? Because this means whatever, or. So that's your hint on that one. All right. Okay, so let's take a look. Let's take a look here at what we did last time. So we remember last time the topic was the weakest precondition, right? And we learned the 2 axioms that define weakest precondition, and we proved a couple of these theorems. I think we did P.4.1. So that's what we did last time. Now what we're going to do is we are actually going to talk about program statements in GCL, in the guarded command language. So let's go to GCL. Oh, do you not remember GCL? Let's review that. Actually, we did this last semester. Well, we could make a bet, and then we could go back and because everything's recorded now.
Say what you're going to say, and then we'll let you know if we
Okay, because I remember because we had a little. I remember we had a little table. We had a little table, and we said when we talked about the assignment statement at the very beginning, and we said, oh, this is how you do it in C++. This This is how you do it in the guarded command language, and we had the difference between equals and gets.
Okay,
And,
so formal, like the formal language?
yeah,
Just got a command?
yeah.
Oh, you never said that.
Oh, and that, well,
I would remember that.
okay.
like the first
Anyway, this is, okay, so now GCL is the guarded command language. And I think actually we could probably, here we said assignment.
And C++.
Yes, assignment and equality. Actually, I remember this table.
Yeah, I remember too.
And this was a C++, and this is GCL.
You never said GCL.
Well, what I put? Okay, maybe formal methods. All right. Okay, so assignment in C++ is this symbol. Assignment in GCL is what? Colon equals. Equality in C++ is equals equals. And equality in GCL is equals. So remember, so this is unfortunate, but true. Yeah? And you know, there was an old language, Pascal, that used this for assignment and used this for equality, and it was. And one of the very worst things that they did whenever they invented C, the C language, is they used a different symbol for equality than the mathematical symbol for equality, and it has caused programmers. People who first learning the language, it's caused them grief ever since, because it's a very common mistake when you first learn how to program in C and C++.
Why'd they do that?
To do,
I
well,
kind of like it because of like less than or equal to, greater than.
yeah, it's. I think there is a. You're right. There is a.
Practical reason?
I mean, no. I mean, there is a similar here. Let's do less than or equal. Less or equal. Because here what you do is less than or equal to, and here you do, less than or equal to. But because there's two symbols in a row, this symbol is not on most keyboards. So it's not an ASCII character. So they have to do this in practice. Well, if you're going to use 2 for this, you use 2 for this. So I mean, in that respect, I guess, that was their rationale. It wasn't totally irrational, but anyway. Okay, so now what we're going to do is we are going to start actually learning statements in what is called this guarded command language. And so, these are the symbols we're going to use on this row here. All right, now the first statement that is defined in the guarded command language is up here in P.10, and it's the definition of the skip statement. Okay? So, what does the skip statement do?
Skips the statement?
Yeah, it does. That's exactly right. It skips the statement. In other words, it doesn't do anything.
It doesn't do the execution.
Well, I mean, when it executes, the effect is that it does nothing.
Yeah.
You see what I mean?
Is that for like else
So, and this actually does exist in C. This actually does exist in C++. In C++, you can have what is called an empty statement. In C++, if you just do semicolon on one line by itself, that's the empty statement. And it's equipped, so this is how you do it in C++. Okay?
That's way so.
Or Java,
You have to do that in switch statements sometimes.
Sometimes you.
The last one.
Okay. Now, okay. So what's the point of P.10? So P.10 is the skip statement does nothing. The skip statement does nothing. Okay? Now, what does P.10 say though? It says what?
Postcondition.
It says W. What does WP mean? The weakest precondition. And remember what the types when we do a weakest precondition notation. The middle. No. If you do WP dot.
That's type program statement.
Type program statement.
First one.
Oh yeah.
That was so dumb.
Okay. So it's weakest precondition dot skip dot r. That equivales r. Now what in the heck does that mean? That r.
Well, the whole thing is a Boolean, isn't it?
Yeah.
Yeah, but what does it mean, wp.skip.r equivals r,
It means,
if r,
Program
it
statement.
means the whole thing, the whole triple equals the post condition. Equivalent.
well, it's like this.
Oh, because in order to have the post condition.
The weakest the weakest precondition is a precondition, right?
Gotcha.
The weakest precondition, skip R, the weakest precondition of skip R is a precondition, yeah. And so what this is saying is if R is true and you execute skip, R is guaranteed to be true,
Makes sense.
right? That's the interpretation of this, right? If R is true and you execute skip, R is guaranteed to be true. R is guaranteed to be true. Okay? So now let's take a look at this. Now let's take a look at P.11. P.11 is a proof for you to do in your homework next time. And what does P.11 say? It says if you have the Hoare triple, Q skip R,
They implied.
that equivales, Q implies R.
Is that because nothing happens in the statement, so that means it would have to imply?
Yeah, by definition of skip. How are you going to prove this formally?
We use one of the.
Well, you have to go back. Let's go back. Yeah, we have to go back to the previous. This is what you have to work with. Yeah?
But is there any skip even?
Well, the skip, plus with P.10. You're going to have to use P.10 with some of those previous ones, right?
How can you use this skip is like part of the.
Yeah, well, you're right. P.10 has the weakest precondition things. But what do we have for, but in P.11 we have a Hoare triple.
Yeah, use the whole triple definition.
So you go back.
Bring out-
And
Yeah.
okay. All right?
You know what I'm talking about.
I know what you're talking about. So proof of P.11, you'll get it. This is a short one. Proof of P.11 is homework. Okay. Now let's take a look at P.12. Oh, okay. So now this is another little. Our second statement in our guarded command language, GCL, is called abort. Now, I think you guys are pretty familiar with abort. Have you ever written a program? Well, those of you who have programmed.
Yeah.
Have you ever written a program that crashed? You know what I mean by that crashed? You know, segmentation fault or, bam, and you just had to, yeah, okay. Well, there's actually a statement in guarded command language that crashes your program. It means crash. That a synonym for abort is crash. So P.12, here's discussion. Well, I mean, actually no, there is a statement in C++ and Java.
Q assert?
Yeah, assert. If you put an assert statement in there, and it can crash your program. Or another one is throw an exception. Throw -1.
Oh, return
I've
negative
done
one.
that.
Throw,
I've
so.
done that through our exception thing before.
Oh yeah? Yeah, so that's, okay, so P.12 is the abort statement causes the program to fail. Abort. Abort statement causes the program to fail. All right? Now, what's the definition of abort? The definition is in terms of the weakest precondition. And what does this say? Weakest precondition dot abort dot r equivales what? False. Now, why is that?
Does the Hoare triple can never execute them?
Yeah, false can never be true, so therefore you can never, yeah. So abort can never establish its postcondition because its precondition can never be true. abort can never establish. You see why it's defined that way? Establish its postcondition because its precondition can never be true. You see?
Why can't it be true?
Because it's precondition, because the weakest precondition of abort by definition equivales false. You see what I mean? Okay, so because its precondition,
I always forget the. Okay.
its precondition can never be true. So
Why is that?
because by definition, P.12 says by definition the weakest precondition of abort, the weakest precondition abort.r equivales false.
So the weakest
See, that's by definition.
That means the weakest precondition of the abort statement is false.
Yes.
Aha.
You see? And if the weakest precondition of the abort statement with any postcondition is false, that means abort can never establish its postcondition because its precondition can never be true because by definition it is false.
That means for the whole triple, the precondition has to equal false.
Well, the precondition of the abort is false. Okay? So a program that, and here's the other thing. A program that executes abort is erroneous. You know, it's an erroneous, you would not ever on purpose want to abort your program if you know.
Unless you're crazy.
Yeah, okay. A program that executes abort is erroneous. A program that executes abort is erroneous. Because usually we write programs to do things that are useful. We don't want them to crash, right? I mean, are you with me? All right. And now, what's the next theorem? Check it out. P.13. Q, hor triple, Q, statement abort. Sorry, yeah. Hor triple, precondition Q, statement abort, postcondition R. That equivales, Q equivales false. And that's a short one that you can also prove in the homework, right? Are we good? Now, let's take a look at P.14. P.14 is the definition of composition. Now, here's the thing about composition. This is called statement composition. Now, you guys, let's suppose that you're doing C++ or Java, and you have a statement like this. So here we have C++ or Java. Okay, and suppose you say this. Suppose you say x gets x plus 1, and then you do semicolon, and then you do y gets y plus x, and then you do semicolon, right? Now, in C++ and Java, these semicolons are different from the semicolons in guarded command language. Because in C++ or Java, these semicolons come at the end of each statement. Do you see what I mean? So in C++ and Java, these come at the end. So this is semicolons, semicolon at the end of each statement. Okay. On the other hand, if you do GCL, the way you would do this is you would do x gets x. Oh, sorry, gets. Yeah. So you would do x gets x plus 1, and now semicolon, right, and y gets y plus x, but no semicolon here. Because what happens is this semicolon, this, see, look. Let's do it like this. Whether you write it on the next line or not is immaterial. You should think of this like this. X gets x plus 1, semicolon, y gets y plus x. And what's the difference between a semicolon here and a semicolon here? Here, this semicolon separates two statements. It's a separator. It's not a terminator. Here, this semicolon is a terminator of each line. Here, this semicolon is a separator. This is a terminator of each statement. Here, this is a separator between two statements. You see? Does everybody see the philosophy there? This one's at the end of each statement. This is a separator. This separates two statements. So here, semicolon separates two statements. This is at the end of one statement, each statement, but this separates two statements. It's in between. See, this semicolon is not really in between this one and this one. It's at the end of this one. Right? So this separates two statements. Okay, does everybody see how the difference? And there's a really fundamental difference with in the syntax of a GCL and with C++ or Java with the meaning of the semicolon. Notice that there's no semicolon down here. And so you can write this all on one line like this. You can also write this all on one line, but if you write this all on one line, you would need this semicolon at the end of this statement. You see what I mean? So this is a very, and by the way, that old language that I told you about, Pascal, this is the way you would do it in Pascal. You didn't have to have the semicolon at the end of the second statement.
So you're saying Pascal was better than C++?
That's a yes. Yeah, there are. I think the advantages outweigh the disadvantages. Yeah, the syntax. Well, they were both developed about the same time, and no, they were both developed about the same time, and people who were doing the people the Kernighan and Ritchie are the people who were developing the Unix operating system, and C was invented to write the Unix operating system. And so they needed a language for a specific purpose, and so for their purposes, and they thought it was going to be a specialized language. They had no idea the thing was going to take off like it did, And so it had a lot of really, really good features, and it has low-level features that you need to write an operating system. So for writing an operating system, C is better. C++ was better. C was invented before C++. But anyway, but then once they had these conventions for the assignment statement and the equals, then everybody said, oh, well, we'll do it the way they did it. Oh, and so it's kind of like C++ and Java 1 in the marketplace.
Like the race between Blu-ray and DVD HD.
Yeah, competing. But the nice thing, but GCL, we will always use this convention in GCL because the characteristics of GCL is invented for theory, for proofs. See, so whenever you want to reason mathematically about your programs, it's much more convenient to use GCL. All right, so now let's get back to P.14. P.14 is called the definition of competition. Now look at P.14. The weakest precondition. Now what do we have for the statement part of the weakest precondition? We have what? S, what? Semicolon T. So that semicolon is a semicolon that separates S and T. Notice that there's not a semicolon after the T. S is a statement, T is a statement, and the semicolon is in between them. There's not a semicolon after the T, right? So, and what does it mean? What does this composition mean? What it means is that if you have the weakest precondition, now this is how you do two statements. The weakest precondition of one statement, and then after that another statement, is defined to be what? What is it defined to be? What does it say in P.14? How do you find the weakest precondition? How do you find the weakest precondition if you have two statements, one right after the other one? What do you do first? First you do what?
One of them.
Yeah, and which one? No. What does the parentheses say? Anytime you have parentheses, what does that mean?
Oh,
Do what's in parentheses first, right?
The second one.
Oh, sorry, I didn't hear
Yeah,
it.
he said that.
Sorry.
You were listening to me for a change.
Yeah. For a change. Okay, so it says you do the weakest precondition of T and R, and then once you do that, then you do the weakest precondition of S with that as the post condition. So in words, what would this say? How would you say this in words? You would say
T and then execute T.
well, no, you would say
Weakest precondition.
wait, hold on. You would say when you do WP, I'm going to have to write this down. If we do WP.S.R, what is R? Is R the precondition or the postcondition? That's the postcondition, right? Are you with me? That's the postcondition. So what does this say? This says that the postcondition of S is the what? Is the weakest precondition of T.
Right.
Are you with me? So here, if you have statements like S, T. Oh. Okay. So if you have S followed by T, what this says is that the postcondition of S is the weakest precondition of T. Yeah? The postcondition of S is the weakest precondition of T. That's what it means for one statement to follow another one, formally. All right? And do we ever prove P.14, yes or no? No, it's a definition. Okay? So, P.15, what does P.15 say? It says
the exact same thing. Basically, you're saying that the weakest.
Oh, well,
precondition-
haha. Yeah, I guess we just said in words what P.15 is, right? If a hor triple QSH and a hor triple HTR, then that implies hor triple QS followed by TR. Okay? Now, and what about P.16?
Why does that
Wait,
okay.
yeah.
Well, you can prove it.
Could it not be equivalence though? 'Cause if it's
No, no.
Yeah, why can't it be equivalent?
No. Mm-mm. You can't prove it with equal. No, it implies. It can't be equivalence.
Why?
Well, I'm not sure I know how to explain it. Okay. Now, let's take a look at 3. So I'll leave that with you. Now let's take a look at P.16. Identity of composition. Now here comes. I want to do this proof because this is the first time we're going to do a proof that two program statements are equal. Two program expressions are equal. So let's take a look at P.16. P.16. Proof. Yeah, we're going to prove it right now. It's real short. It won't take very long. Now watch this, you guys. What do we have here? Let's take a look at P.16a. What is the type of this on the left-hand side of the equals? What is its type? Is it Boolean, integer? What is it?
Boolean.
Program statement.
It's a program statement. Are you with me?
Is the semicolon?
Well, yeah, S is we know skip is a guarded command language statement, and S is a statement, and semicolon is this what have you know, and so what is the type of what we have on the right-hand side?
Also,
It's also it has to, because with equals you got to have same type on both sides, right? So we're
Oh, never mind.
Are you with me? So now what does it mean for this statement? How does it mean for two statements to be equal?
How can skip be equal to S?
No. It says if S followed by skip, we're saying that equals S.
Oh, right.
We're saying those two statements.
Precedence on-
This, are you with me?
Yeah, man.
Okay. So now, how do you, but no, look, how do you prove, we mentioned this last time, how do you prove that two statements are equal? That two programs are, how do you prove that two programs are equal? You let what?
Slide the fall.
Yes. You say,
Infinite limit.
what is it?
An arbitrary postcondition.
Yeah, here, program equivalence,
Postcondition.
P.6. So for all,
Prove that the weakest precondition of one statement
yes,
dot that arbitrary postcondition equal. Yeah.
exactly. So we let R, so here's how you have to write this out in English because we can't, yeah. Right, this is like proving two sets, right? Let V be an arbitrary element. Prove that if V is an element of T, S equals V is an element of T, right? So here, it's only this is not an arbitrary element. What is it? Let R be an arbitrary what?
Postcondition.
Not a program. It's a Boolean. It's a postcondition. Are you with me? Keep
Not really.
keep
I
the.
don't understand why it has to be.
Let R be an arbitrary postcondition.
Because they have to have the same postcondition.
Yeah, exactly.
Yeah. And from P.6, what must we prove? From P.6, we must prove. So let's write down what we have to prove. So tell me, from P.6, what do we have to prove? So in this particular example, we're trying to prove S skip equals. So what must we prove? Let's write down what
Weakest precondition dot
WP dot.
skip. Yeah.
Well, let's do the left-hand side.
Oh, sorry.
Dot what? S semicolon skip dot what? R equivales what?
Weakest precondition.
WP dot
S
dot S dot R. Now is everybody clear with that? Now which side do you want to start with? The left-hand side or the right-hand side?
Left-hand side.
I think so too. So here's the proof. WP dot S semicolon skip dot R equals by what? What can we do? What can we do, sports fans? What can we do here? What do we have to work with?
The semicolon thingamajig.
Yeah, we had the semicolon thingamajig. So by semicolon thingamajig.
Yeah.
It
I
is.
think you went on the wrong.
Oh, I think I went the wrong way?
Easy there.
Yeah.
Oh, you're right, went the wrong way. So by P.14, so what does P.14 say?
Weakest precondition
WP dot what?
S
Dot S
dot weakest precondition
dot, yeah, and let's put this in paren just for emphasis, dot what?
dot weakest preconditions dot skip.
Dot skip
Do you have to put it in the parentheses there, or can you?
dot R paren.
Now
Yeah, you actually should because you got a dot and a
I
dot.
said put it for clarity.
Well,
put in
okay.
P10.
Equals by what?
P10.
Say it again, P10? Because we already know, so P.10. But what do we know about P? Weakest precondition dot skip dot R?
It's R.
That's R. So this equals
Boom.
WP dot S dot R. Boom, boom.
There you go, sports fans.
There you go, sports fans. What'd you think about those
How do you like
Steelers or?
Oh, that was BS. Should've got that. Yeah, I was just was so close. Put it away.
that? Way better.
No, really.
Okay, so there you have it, sports fans, and I'll see you next time.
Go Green Bay.